Hello everyone, this is Moshimi and welcome to aptdemy. Today we shall be discussing vectors. Now what really vectors mean? Why are they important? These are the subtopics that we shall be covering under this chapter. Now the entire concept of vectors comes from direction. There are some quantities in science which need the effect of direction, where the effect of direction has to be specified. For example, when you are considering the force acting on a body, you need to mention the direction. So this small concept of direction makes vectors very important subject. Now, first we have to know what are physical quantities. Now, all measurable quantities, any quantity that you can think of which can be measured, not talking about love, hatred, etc. But besides that, like mass, length, time, and so on and so forth. There are all such quantities which can be measured. They are called physical quantities. Now, physical quantities have been broadly classified as scalar and vector quantities. Now, scalar quantities are those which can be represented by their magnitude and unit. So, we have a numerical value and we have a unit which helps us to specify scalars completely. Examples of scalars are length, mass, time. So for example, you have a rod of a certain length, say 2 meters. So that means to specify length, you are using two things. One is a numerical one is a number, that is the number 2, and another is the unit, say meters. So these two things are sufficient to explain scalars. But in case of vectors, there is an additional requirement, which is the direction of the quantity. So vectors are those quantities which have both magnitude as well as direction. And examples of vectors are force, velocity, acceleration, and so on. Now, besides scalars and vectors, there is also a third category of quantity which are called tensors. You should learn about that in higher levels. But to give you an idea, a tensor is basically a mathematical object that specifies the position. It is in fact a generalization of scalars and vectors. For example, a scalar, you can think of scalars as 0 rank tensor, while vectors are rank 1 tensors. Now, another main difference between scalars and vectors is that scalars can be added by using ordinary rules of algebra, while those rules do not hold good in case of vectors. Vectors are added by vector laws of addition. Now, to represent scalars, we use alphabets, while to represent vectors, we use alphabets with an arrow over them. For example, if you are to represent graphically a vector, you write it somewhat of this form. Say A is a vector, you want to represent this as a vector, you have to write an alphabet and you have to give an arrow on top of it. So this will represent a vector graphically. Now in writing, when you want to mention the magnitude of a vector, you can write it as modulus vector A, which can also be written as simply A. So when you are writing this, you are referring to the magnitude of a vector. Now, what is the importance of vectors? Vectors appear very complex looking. Then why are they important? There are many reasons for that. First of all, the laws of physics can be expressed in a compact form with the help of vectors. So talk about the Coulomb's law, the law of gravitation, the Biot-Savart's law, whatever. All laws can be expressed in very compact form with the use of vectors. The second importance of vectors is that many derivations in physics become simplified with the use of vectors. Moreover, the laws of physics remain invariant under rotation and translation when expressed in vector form. So whenever you are expressing the laws of physics in vector form and you are applying a rotation or translation of the coordinate system, then these laws do not change their form. But mind it, this is true only for a 2 pi or a multiple of 2 pi rotation of the coordinate system. Now there are various types of vectors. First, we shall talk about collinear vectors. As you can see from the diagram, collinear vectors are vectors of equal or unequal magnitude but directed in the same direction. So these are two vectors. They are represented by arrows, and each vector, the two vectors may have equal magnitude or they may be of unequal magnitudes, but they are collinear so long as they are pointing in the same direction. Talking about co-initial or concurrent vectors. Vectors which originate from a common initial point are called concurrent or co-initial vectors. You can see from the point O, three vectors are originating, vector A, vector B and vector C. So these vectors are co-initial or concurrent vectors. Unit vectors, just go by the name, unit vectors. So this means these vectors have unit magnitude and their direction is same as that of the given vector. So if you have a vector, vector A, then if you want to write the unit vector of that particular vector, you will represent it by A cap. So you write it in this way. You have a vector A and you want to represent the unit vector of vector A. You shall write it as A with a cap on its head. So this is a unit vector. Now orthogonal unit vectors. These are also unit vectors, but they are mutually perpendicular to each other. These are the I cap, j cap and k cap vectors. As you can see from this drawing, if I consider O as the initial point of the coordinate system, this is the x-axis OX, this is the y-axis and this is the z-axis, then the unit vector along x direction is given by I cap, the unit vector along y direction is given by j cap and the unit vector along z direction is given by k cap. Now coplanar vectors also go by the name. These vectors lie in the same plane. So if you are considering that particular coordinate system where you can write the axis as x, y and z, then these vectors which lie in any one particular plane are the coplanar vectors. So considering the xy plane, vector x minus vector y, this is a coplanar vector similar as vector y minus vector z and vector x minus vector z. So these are all examples of coplanar vectors. Now position vectors. We know that the position of any object can be specified by specifying its coordinates. Now when we are talking of a two-dimensional object or an object moving in the two-dimensional space, then in order to specify its position, we have to use the x and y coordinates. So position vectors are those vectors which are drawn from the origin to the position of a particle at any instant in the plane. So you can see this, we have the xy plane and the position of any object at say point P is represented by vector r, where vector r is the position vector and P is the position of the object. So this position vector, we can express it in terms of x and y coordinates as well. Now zero vector or null vector. As per the name, it is that vector which has got zero magnitude and an arbitrary direction. Now let us think of real life examples to this. Suppose you have a body which is at rest. Now, when a body is at rest, does it have any velocity? No. So that means that velocity vector of an object at rest is an example of a null vector or a zero vector. Similarly, whenever a body is moving with uniform velocity, its acceleration is 0. So the acceleration vector of an object moving with uniform velocity is a null vector. Now resultant vector, this is a very important concept to deal with, which is of particular importance also in case of numericals. Now the resultant vector of two or more vectors is defined as that single vector which produces the same effect as is produced by the individual vectors. So thinking of this, let me show this with an example. Suppose you have two vectors, vector A and vector B. Now, these two vectors, suppose you want to find out the resultant of the two vectors. Now, the resultant of these two vectors will be given by a third vector, vector R, which will produce the same effect as is produced by these individual vectors together. Now let us discuss how vectors are added. So we are discussing the algebraic rules of addition and we are relating that to that of vectors. Now vectors are added geometrically by tip to tail method. So what does this mean? Whenever we are talking of a vector, the starting point of a vector is its tail. So if this is a vector, then this starting point is the tail. And this is the head of the vector. So at the time of addition, they are added, vectors are added by the tip to tail method. But mind it, you have to be careful about the angle made between the vectors, which does not follow this particular rule. While deciding the angle of inclination between the two vectors, you have to take special notice. Now let us discuss the two important methods of addition of vectors. The first method is the triangle law of vector addition. Now if two vectors are represented in magnitude and direction by the two sides of a triangle taken in one order, then their resultant, vector R, in both magnitude and direction is the third side of the triangle taken in opposite order. So what does this mean? Let us see with the help of this drawing. We have two vectors, vector A and vector B. Now how to choose the angle between the two vectors? Now look at this. This is the tail of vector A and this is the head of vector A. So what we are doing is that we have another vector, vector B, but the tail of the vector is joined to the head. So at the time of addition, we cannot decide the resultant considering this particular angle as the angle between the vectors. Why not? The reason is that vectors are to be added by tip to tail method. So what we are to do is that we have to replace this vector A by this particular vector. So when we are adding these two vectors, vector A and vector B, then the resultant is actually this. And then the angle between the two vectors will be considered as theta. So whatever method we use, ultimately the magnitude of the resultant is got by this formula which says R equals A square plus B square plus 2AB cos theta. So this is R square. R square equals A square plus B square plus 2AB cos theta, where theta is the angle between the two vectors. Now alpha is the angle made by the resultant with one of the vectors, and tan alpha is given by B sin theta by A plus B cos theta. These formulas can be very easily derived using the rules of geometry. Now next we shall talk about the parallelogram law of vector addition. Now, if two vectors are represented both in magnitude and direction by the adjacent sides of a parallelogram drawn from a point, then the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram drawn from the same point. So we have two vectors here, vector A and vector B, and the angle between the two vectors is theta. The two vectors are representing the adjacent sides of a parallelogram. Then the resultant of these two vectors will be given by the diagonal of the parallelogram drawn from the point where the two vectors meet. So vector R will represent the resultant of the two vectors, vector A and vector B. Let us look at this in some more detail. So this is the formula that we get here, and we shall be observing certain special cases when theta changes from 0 to 180 degree. So let us write down these expressions separately. So the formula for the resultant is the same as that obtained in case of triangle law of vector addition. So this is r square. Now look at this. We have r square equals a square plus b square plus 2ab cos theta and tan alpha, where alpha is the angle made by the resultant with the vector A, and tan alpha will be equal to b sin theta by a plus b cos theta. Now solving the first equation, we can get an expression for cos theta as r square minus a square minus b square by 2ab. Now this is the law of cosines. The law of sine says r by sin theta equals a by sin alpha equals b by sin beta, where beta is the angle which vector b or the resultant vector r makes with vector b. Now discussing the special cases. So we have the resultant r square as equal to a square plus b square plus 2ab cos theta. Now some books might be showing you this expression with a negative sign. So that doesn't matter, it only depends on how you are choosing the angle between the two vectors. So wherever there is a negative sign, it means that they are referring to the other angle made by the vectors. But you have to be sure about the direction of the vectors and accordingly choose the angle. So the different special cases that we'll talk about here is when theta varies from 0 to 180 degrees. So if theta is 0 degree, what happens to r? So r square becomes equal to a square plus b square. Now what is cos of 0 degree? Cos of 0 degree is 1. So cos theta becomes 1 and we have r equal a plus b whole square. R square is equal a plus b whole square, or r equals a plus b. Now this is the maximum value that the resultant of two vectors a and b can have. So this is actually r max. So r max is possible only for theta equals 0 degree. Now try to remember this because this will prove to be of great importance in solving numerical problems. Now when theta is equal to 180 degree, what happens? R square becomes equal to a square plus b square, and cos of 180 degree is minus cos theta. 180 minus theta, cos of 180 degree is equal to minus 1. So this becomes minus 2ab. Cos theta is minus 1. So ultimately we have r equals a minus b. So the resultant of two vectors is minimum when theta is 180 degree. So this is actually the minimum value of resultant which is obtained for theta equals 180 degree. Mind here, theta is the angle between the two vectors. Now what if theta is equal to 90 degree? Now when theta is equal to 90 degree, cos 90 becomes equal to 0. So we have r equals root over a square plus b square. So these are the cases that arise in case of parallelogram law of vector addition, or even these cases may arise in case of triangle law of vector additions. Whenever we are talking of vectors, these cases are bound to arise. So you have to be careful while solving numericals. Now, the condition for zero resultant vectors. When is the resultant of two vectors or two or more vectors zero? So the condition is that if three vectors are acting on a point object at the same time and they are represented in magnitude and direction by the three sides of a triangle taken in the same order, then the resultant of the three vectors becomes equal to 0. So if we want to represent this diagrammatically, we can show this in this manner. We have a triangle, say, this is one vector, this is another vector, and this is the third vector. So you can see that these three vectors are represented by the sides of a triangle taken in the same order. If we start from here, we'll end up at the same point. So in this case, we can say that the resultant of these vectors is equal to 0. Or vector A, if these are vectors, vector A, vector B and vector C, then we can write that vector A plus vector B plus vector C is equal to 0. So this brings us to the Lamy's theorem. Now, Lamy said that if there are three forces which are acting at a point and these forces are in equilibrium, suppose we have a point and three forces, vector A, vector B and vector C, these are three forces and they are acting on the point object which is at the point O, say. This is the point O. Then Lamy says that if these three forces, vector A, vector B and vector C, they are in equilibrium, then each of the force will be proportional to the sine of the angle between the others. So let's have a look at the formula. A by sine alpha. Now note, we are considering vector A. Now we have to see the angle made with the other vectors. So what is the angle made with the other two vectors? That's alpha. So A by sine alpha is equal to B by sine beta is equal to C by sine gamma. So these three components are equal. Now talking about the properties of vector addition. The first most important property is that forces of the same nature can only be added. What does this mean? That if you have a force vector and if you have a velocity vector, say, you cannot add them to get a resultant. Forces have to be of the same nature. Only then they can be added. Then vectors follow the law of vector addition and the vector addition is commutative. That is, vector A plus vector B will be equal to vector B plus vector A. It is associative. Vector A plus vector B, the sum added to vector C is the same as vector A added to the sum of vector B and vector C. It is distributive. That is, if you have a scalar quantity lambda and you multiply that lambda with the sum of two vectors, vector A and B, then it produces the same effect as you multiply lambda with vector A and you add the result to lambda multiplied with vector B. Now take a note at this. Whenever we have a vector and we multiply it by a real number, what does happen as a result of that? Suppose we have a vector, say vector A, and we multiply it by a scalar, say n. Let me first talk of a real number. Suppose n is a real number. Then what happens is that we get a new vector n vector A whose magnitude is n times the magnitude of vector A, and the direction of this new vector, however, will depend on the type of real number that we have chosen. That is, if the real number is positive, the direction of the new vector will be same as that of the initial one, but if n is negative, then the resultant or the new vector that is produced will have a direction opposite to that of the original vector. Now, what if n is a scalar quantity? If n is a scalar quantity, then the product of n and vector A will give us a new vector vector A whose magnitude is n times that of the given vector A. So these are certain tips that you have to remember, which will be of importance while solving numericals. Now, two most important concepts in vectors, and you are sure to get a question on these parts. They appear difficult, but you understand the concepts and it becomes very easy. So let's have a look at the first one. A boat crossing a river along the shortest path. Now remember, whenever a boat is crossing a river, it always moves in the direction of the resultant velocity of the boat and that of the river. So the boat has a velocity of its own, say we take it as vector v1, and the river by itself has a velocity of its own, say we take it velocity v2. Then the resultant of these two velocities, vector v1 and vector v2, is represented by vector v. And the boat, while crossing the river, it actually moves in the direction of this resultant velocity. So whenever a boat is tending to cross the river along the shortest path, it will have to row upstream such that it makes an angle theta with AB. You can see in the drawing AB, the boat has to move upstream making an angle theta with AB such that vector AB will give the direction of the resultant velocity. Now let's have a close look at the diagram. So A is the point from where the boat starts rowing. The velocity of the boat is given by vector v1 or vector AD, and the velocity of the river is given by vector v2 or vector AC. Theta is the angle that the boat makes with the resultant velocity vector v. So the resultant velocity here is given by vector AB or vector v. So this is a vector quantity. Vector v. Now how do we find that out? If we want to find out theta, we can apply any formula for it, but theta, sine theta, if we find out, then sine theta is equal to perpendicular upon hypotenuse. So for this angle as theta, the perpendicular stands as v2 and the hypotenuse is v1. So sine theta becomes equal to v2 by v1. And where v, how can we express v as? If you take a note at this triangle ABD, it is a right angle triangle. So the resultant is v. We can write by Pythagoras theorem, v1 square is equal to v2 square plus v square, which gives us v as root over v1 square minus v2 square. So it is not necessary to remember these formulas, but this drawing should be in mind so that you can apply the drawing and find the result. Now the time taken by the boat to cross the river. Time is nothing but distance covered by the velocity. So the distance covered is the width of the river, which is given by S, divided by the velocity, which we have found out as root over v1 square minus v2 square. So this is what happens when a boat crosses a river along the shortest path. Now let us look at the next case, which is the boat crossing the river along the shortest time or in the shortest time. So the same thing holds good here. A boat in a river always tries to cross the river and it will try to move in the direction of the resultant velocity. But as it is intending to cross the river in the shortest time, it has to go along AB, because this is the horizontal, this is the perpendicular distance between the two ends of the river. So just have a look at it. We have this diagram. At A, the boat is initially at the position A, and it is moving through the river. It crosses the river. The velocity of the boat is given by vector v1. Now, theta is the angle that v1 makes with the resultant vector b. V and v2 is the velocity of the river. Now, if the boat is trying to cross the river along AB, then by the time it crosses and reaches the point, it has already traveled a certain distance because of the velocity of the river, and it reaches the point D instead of the point B. So tan theta from this drawing is clear. Tan theta is equal to perpendicular by base, that is BD by base, which is AB. So we can see BD has been considered to be x here. So we can write tan theta as equal to x by V1 or x by S. S is the width of the river. We can also write an expression for tan theta as V2 by V1. So these two formulas hold good, and they actually represent the same thing. Now talking about V here, if you can see, ABD is a right angle triangle, and the hypotenuse square is equal to the sum of the squares of the perpendicular and base by the Pythagoras theorem. So the same theorem has been applied here. We can write V square as equal to V1 square plus V2 square here. So this is the formula for tan theta, which will give you the direction of the boat, and this is the resultant velocity. Now time taken by the boat to cross the river, ultimately the boat is following the path AD. So AD is the hypotenuse, or we can write it as square root over S square plus X square. So AD is nothing but, AD square is nothing but equal to AB square plus BD square. Now AB is S, so this is S square, plus BD is X, so this is X square. So you can put this in the formula and get the result. But again, I would like to remind you, it is not important to learn these results. You need to be clear with the diagram. Now, we have talked about vector addition. Now next we come to subtraction of vectors. So subtraction is nothing but similar to addition. So whenever you are saying that a vector B is subtracted from a vector A, it means that you are actually adding minus vector B to vector A. So you can have a look at this diagram. We have vector A and vector B, and they are inclined at say some angle theta with each other. Then if you want to add the two vectors, then there are two methods, the triangle method and the parallelogram method of vector addition. So the similar two methods may be used for subtraction as well. Now let's have a close look at the diagram. We have vector A, this is vector A along this particular direction, and this is vector B. Now, how will you add the two vectors, vector A and vector B? You can add it if this is the angle between the two vectors. This will give you the resultant of the two vectors by triangle law of vector addition. But we want to find out the resultant of the difference of the two vectors. So for that, what we do is that we replace this vector B, we change the direction, and then changing the direction will convert vector B to minus vector B. So the direction of minus vector B is this. Now we can find the resultant of these two vectors. This is vector R by the triangle method of vector addition, and vector R can be written as vector A plus minus of vector B, which is this particular formula. Now by the parallelogram law of vector addition, we can advance in this manner. This is our vector A and this is minus vector B. You can see that if you consider this as the common point, these two vectors are representing the adjacent sides of a parallelogram. So the diagonal drawn from the point where the two vectors meet will give you the resultant, and the resultant is the same, that is vector A minus vector B. Now vector subtraction, however, does not obey commutative or associative laws. Now we are over with addition and subtraction of vectors. Now it's time for product of vectors. Whenever we are talking about product of vectors, there are two main ways. One is the scalar product of vectors, also called the dot product, and the other is the cross product of two vectors. Now these are two very important concepts in vectors on which lots of numericals come. So let's have a close look at the formulas. Scalar product of two vectors, vector A dot vector B, is given by AB cos theta. Now, in case of orthogonal unit vectors, I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap equals 1. So, these are very important formulas. While if you are taking the dot product of two different combination of unit vectors, that is I cap dot j cap or j cap dot k cap or k cap dot I cap, all these amount to 0. So we are to remember this for numericals. Now, for two parallel vectors, this is another very important, as I call, helpers. These are our helpers. So these are my helpers, and you will see their help very soon. So for two parallel vectors, dot product is equal to AB. So this is nothing hard. Even if you don't remember, you have to be clear with the base formula, which is vector A dot vector B, which is equal to AB cos theta. So just have a look at it. For parallel vectors, what will happen? Theta becomes equal to 0 degree. So we are left with vector A dot vector B equals AB. For equal vectors, what happens? You have B is equal to A. So vector A dot vector A, and the magnitude of two equal vectors is equal to A square. For two perpendicular vectors, put theta equal 90 degree. You will get vector A dot vector B as 0. This is of particular importance. For two antiparallel vectors, which means that theta between the two vectors is 180 degree, we have vector A dot vector B is equal to minus AB. So just put theta as 180, it becomes minus AB. Now in terms of components, how you can write down or how you can express dot product of two vectors. Now here they have expressed in terms of 3D components. So vector A dot vector B is equal to AX BX plus AY BY plus A suffix Z B suffix Z. Now cross product of vectors. Now vector A cross vector B is equal to AB sin theta n cap, where n cap is the unit vector in the direction perpendicular to the cross product vector. Now I cap cross j cap is equal to j cap cross j cap is equal to k cap cross k cap, which is equal to 0. So cross product of two similar unit vectors is 0. And I cap cross j cap is equal to k cap. Now this order has to be cyclic. So if you are taking I, j and k caps, then the order should be cyclic, that if you take the cross product of I and j, it has to be k. If you are taking j and k, it has to be I, and if you are taking k and I, it has to be j. Now if you change the order, you will get a sign change as well. For example, in place of I cross j, if you are trying to write down the value of j cross I, it will be minus k cap. So you have to be careful while solving numericals, because a change in sign will change the sum. Now, we can express cross product of two vectors in terms of determinants. So this is also very beautiful and it applies to a lot of numericals. So you can see determinant I cap, j cap, k cap, and the second row ax, ay, az, these are components of vector A in the three directions, And b suffix x, b suffix y, b suffix z, these are the components of vector b in the 3D coordinate system. And if you are finding out a cap vector A cross vector B, then you can write this in this order. As I mentioned, the cyclic order has to be followed. So when you are taking I cap, you have to neglect the order. The order which is followed for solving determinants is that neglect the particular row and neglect the particular column and continue with the next. So just have a look at this, how this is derived. Now you have to neglect this particular row, neglect this particular column, and then you are left with I cap into AYBZ minus BYAZ. Now whenever you are considering the middle, you have to neglect that particular row and the particular column and continue. You are at AZ, so you start from AZ, AZBX minus BZAX. And when you are doing the same with K cap, neglect that particular row, neglect that particular column in which K cap lies and consider the remaining. Where were you? You were at AX, so start from AX. AX BY minus BX AY. So this is a very easy method to calculate the cross product of two vectors, the determinant method. Even for bigger numbers, this method applies good. Now we shall talk about resolution of vectors. So what is resolution? Just go by the name. Resolution is the process of splitting a single vector. You split a single vector into two or more vectors in different directions, which together produces the same effect as is produced by the single vector alone. So you have vector r and you want to split this vector r into two vectors. So you have splitted this vector r into vectors vector a and vector b such that the effect that r had produced will be equal to the effects produced by vector a and vector b together. Now these two vectors into which r got split up, that is vector a and vector b, these are called the component vectors. Now, resolution of a vector into two rectangular components. Now we are talking of two dimensions. We shall consider the resolution of a vector into two rectangular components, and we shall consider the resolution of a position vector into two rectangular components. So let us have a look at the formulas. Now suppose we have a vector A which is making an angle theta with the x-axis. So you can have a look at the diagram. It is making an angle theta with the x-axis, and the components of vector A in the x direction is given by AX, and the component of vector A in the y direction is given by AY. So we can write the vector as a whole as vector A equals AX I cap plus AY j cap. So this is the way in which we have resolved vector A into two rectangular components. These are the two rectangular components of the vector. Now this AX is equal to A cos theta. This is the horizontal component of the vector, and the vertical component of the vector is given by AY, which is equal to A sin theta. Now the angle between the vectors. To find out the angle between the vectors, we can find out tan theta. Tan theta is nothing but equal to AY by AX. So these formulas are also required while solving numericals. Now if we want to represent the position vector of an object, similarly we can write the position vector as vector r, which is equal to I cap, the x component here is given as x plus j cap, The y component is y, where I cap and j cap are unit vectors. In fact, we can call them orthogonal unit vectors along the mutually perpendicular directions. So in the coordinate system, the x, y and z axes are mutually perpendicular to each other, which make I cap, j cap and k cap also mutually perpendicular to each other. And here the magnitude of of vector r can be written as simply r, which is nothing but square root over x square plus y square. Here too we can write out the magnitude of the vector. The magnitude of vector A is nothing but square root over ax square plus ay square. So this is in terms of 2 dimensions. Now we can similarly write down expressions for the vectors in terms of 3 dimensions. Now have a look at this. If we have a vector A which is expressed in the 3-dimensional coordinate system. So let me try to explain this with a diagram. Now suppose we have a vector A and the components of vector A in the mutually perpendicular directions are given by ax along x direction, ay along y direction and az along z direction. So suppose this is x. Let me take this as x. So this is, So this is taken as xa, this is y and this is z. So along x direction, the component we take it as ax. Along y direction, this is our vector az, making an angle theta with the horizontal or whatever. This is the x component of the velocity, of the vector, This is the y component given by ay and this is the z component given by az. Now the angles made is alpha with the x-axis. So if this is the x-axis, this is alpha. We have beta with the y-axis. So this is beta and gamma with the z-axis. So let me make this a bit deeper. So this is gamma. Now let's look at the formulas. We can express vector A in terms of components as vector A equals ax I cap plus ay j cap plus az k cap. And the magnitude of the vector can be written as square root over ax square plus ay square plus az square. Now if alpha, beta, gamma are the angles made with the 3 axes respectively, then we can write cos alpha as equals ax by a, cos beta as ay by a and cos gamma as az by a. Now these cos alpha, cos beta and cos gamma, these are called the direction cosines of the vector A. And the sum of the direction cosines is equal to 1. Now similarly, we can apply this formula for resolving a position vector into 3 components. Now the position vector r, we can write it as I cap x plus j cap y plus k cap z. The magnitude of the vector being r equals square root over x square plus y square plus z square. Now time for helpers. A vector can have infinite components, but the maximum number of rectangular component vectors are 3. So this is true. We can have infinite components for a single vector, but rectangular components, when we are talking of that, we can have a maximum of 3 in 3 dimensions. And in case of 2-dimensional, we have a maximum of 2 components of a vector. Now the minimum number of vectors to give 0 resultant is 2 in one plane. So if you are talking of vectors of the same magnitude, then the minimum number of vectors that can give the same 0 resultant is 2. Now if modulus or the magnitude of vector A plus vector B is equal to the magnitude of vector A minus vector B, then the two vectors are at 90 degree with each other. So this can be solved to get the result, but it's better to know the formula. If vector A plus vector B is equal to vector A minus vector B, then vector B has to be a null vector. Now, I cap plus j cap plus k cap, they together make an angle of 54.74 degree with each of x, y and z axis. So, isn't this interesting? Now, where do we apply resolution of vectors? So, it has a everyday application where whenever we are walking, what we are doing? We are actually pressing our leg on the ground. Now, when we are pressing the ground with our feet, we are doing that by applying a certain force at a certain angle with the ground. As a result, the ground too, in return, offers a reaction force. Now, this reaction force which has been offered by the ground can be resolved into two rectangular components, r cos theta, which helps the man to move forward provided it is greater than the force of friction, and r sin theta, which balances the weight of the man. So this is where resolution of vectors are applied on a daily basis. Now let's have a quick look at certain important multiple choice questions on vectors. So here comes the first one. Vectors vector A and vector B are parallel if, which of the options is correct? For parallel, we'll go by vector A cross vector B is equal to 0. You can think on this. Parallel means theta is 0 degree. Now, cos theta, if you are thinking of dot product, cos theta becomes 1. But then we are left with components, that is magnitudes in fact, of vector A and vector B. So, the first option A and the third option C are out from the answer sheet. So we are left with the answer number vector D. Now the second problem, vectors vector A and vector B are perpendicular if. So we remember the helpers, it is vector A dot vector B equals 0 because theta is 90 degree. So you can just do this in a second. Theta is equal to 90 degree. So which means that I'll check the option vector A dot vector B, which is equal to AB cos theta. Now cos 90 is 0, so we are left with vector A dot vector B is equal to 0. So this option C turns correct. Now the magnitude of vector A cross dot vector B dot vector A is A square. So these are very easy problems. The minimum number of unequal forces that may be combined to give 0 resultant are. So we have already discussed this a bit before. This is 3. The rectangular components of a vector are ax equal half and ay equal root 3 by 2. The angle at which vector is inclined with the positive x-axis is. Now to find out the angle once the components of the vectors are given is very easy. So what we have to do is apply the formula, that is tan theta, the angle between the vectors, or the angle the resultant makes with the x-axis is given by ay by ax. So this is root 3 by 2 over half. So we are left with tan theta equal root 3, which is theta equals 60 degree. A boat having a speed of 5 kilometers per hour in still water crosses a river of width 1 kilometer along the shortest possible path in 15 minutes. The speed of river water in kilometers per hour is. So a very beautiful problem. Let us start with this. So there is a river The width of the river is given by S, which is equal to 1 kilometers. The time taken to cross the river, T, is given as 15 minutes. We will convert this to hours as all other units are in kilometers and hours. So this is 15 by 60 hours, which is 1 by 4 hours. Sorry, 1 by 4 hours, yeah. Now, we have the speed of the boat. So the boat is traveling. He wants to move along the shortest path, for which he will have to row upstream. If you remember the concepts, we are given with V1 the speed of the boat, which is equal to 5 kilometers per hour. We need to find out the speed of the river water. Now we assume that speed of river is V2 kilometers per hour. Now the first thing is that what we have to do is we have to use the expression for the time and find out the resultant velocity. So this is V2, the velocity of the river, and this is the resultant velocity vector V. So let us first find out V, the resultant velocity. We can use time equal distance by speed. So the distance is S and the speed is the resultant velocity T, V. So V will be equal to S by T, which is S is 1 kilometers and T is 1 by 4. So we get V, the resultant velocity, as 4 kilometers per hour. So this is the resultant velocity. Now we are asked to find out V2. So let's have a look at the diagram. We can see that this particular triangle, say OAB, is a right angle triangle, and we can apply the Pythagoras theorem to this triangle. And we can write V square as equal to V1 square minus V2 square. So V2 square becomes equal to V square minus V1 square. Now V is 4, so this is 4 square minus V1 is 5. So am I wrong with the signs? Yes. So this is V1 and this is V. This is V. So this is V square. So V1 is 5. This is 5 square and V square is 4 square. So this is 25 minus 16 or 9. We have V2 square equal 9 or V2 equal 3 kilometers per hour. So option D stands correct. What could be the magnitudes of two vectors to produce a resultant of 43? Another beautiful problem. Now, we had discussed one thing in theory, that the maximum resultant of two vectors is the sum of the two vectors, and the minimum resultant is the difference between the two vectors. So let us try and find out and see which combination of vectors will give us a maximum and a minimum, and the resultant which has been given in the question, it falls in which range. So if we try to find out R max for the first option and R minimum for the first option, let's see what it comes up. The first thing that we do is we write down formulas for R max and R minimum. So this is the sum of the two vectors. The sum of the magnitudes of the two vectors, in fact. And the minimum value is the difference in the magnitudes between the two vectors. Now have a look at the options. This is 15 and 15 as the two vectors A and B. So add them up, 30, and the difference 0. So the resultant will be somewhere between 0 and 30, which is not the one given in the question, 43. Now let us see for which option that resultant is possible. You see the option B, the minimum value is 70 minus 30, that is 40, while the maximum value is 70 plus 30 or 100. So it means that a resultant is possible between 40 and 100 for this particular case. So this stands as the correct answer. The difference between two concurrent vectors of magnitudes 3 Newton and 8 Newton is 8 Newton. The angle between the vectors is. So we have two concurrent vectors of magnitudes 3n and 8n, and the difference between the two vectors. Now don't get swayed away. What does this difference mean? This is actually nothing but the resultant of the two concurrent vectors, but you have to be careful with the angle between the two vectors, as the direction of two concurrent vectors are away from each other. So have a look at the formula for the resultant, and then we apply the results to this particular case. So we have R square equals A square plus B square plus 2AB cos theta. Now R, the resultant here is 8. So this is 8 square. One of the vectors is 3 magnitude and the other vector is of magnitude 8 again. So we have 2 times 3 times 8 and this is cos theta. Now have a look at this. What is this theta actually? Whenever we are talking about concurrent vectors, it is somewhat of this sort. This is one of the vectors and this is the other vector. So mind it, we are actually concerned with the angle. So the angle is actually not theta here, but it is actually 180 minus theta. So this is one thing that you have to note here. The angle that we are taking here is not theta, but 180 minus theta. So we get this 8 square can be cancelled out from both sides. Ultimately, what we are left with is cos of 180 minus theta, which is minus cos theta. So we get (48) cos theta equals 9. So cos theta will be equal to 9 by 48, and using the cosine tables, we can get the value of theta as equal to 79 degrees. The direction of two concurrent vectors is shown below. What will be the direction of the resultant? Now you can have a look at the diagram. We have two concurrent vectors. They originate from a common point. So if you are to find out the resultant between the two vectors, the method that you have to follow is the tip to tail method. So you simply think of substituting this particular vector at this particular point. So you imagine this as if you have shifted this vector to this point. So what will be the resultant of the two? It will be in this particular direction, isn't it? So option C stands correct. Now what is the vertical component of a vector of magnitude 10 units making an angle 30 degree with the positive x-axis? So we are to find out the vertical component, which means AY is the vertical component, which is equal to A sine theta. Now the magnitude of A is given as 10 and sine of theta, which is given as 30 degree. So sine 30 is half. So we are left with the vertical component as 5 units. So option A stands correct. Three forces act concurrently at point O as shown below. The direction of the resultant force at O will be best represented by which of the following diagrams? Now have a look at the drawing. We'll simply try to sketch a vector triangle with these vectors following the tip to tail method. Now have a look at this. This was one of the vectors, F2. This was the initial vector, vector F1. And this was the third one, vector F3. So without changing the base directions, let's think of how we can shift the vectors. So imagine shifting F2 to this particular point. So we have F1 here. Without changing the direction of F2, we can shift it at this point. This is F2. And without changing the direction of F3, we can shift it at this particular point. So this is F3. Ultimately, what is the direction of the resultant here? The resultant is given in this particular direction. This is the resultant. So you can see that option C stands correct. A river flows from west to east at a speed of 5 meters per second. In what direction should a man on the south bank of the river swim so as to cross the river in the shortest time if he can swim at 10 meters per minute in still water? So let me do the diagram. Now the river, this is the river of certain width. The river is flowing, that is V2 is equal to 5 meters per minute. And the swimmer, he wants to cross in the shortest time. He's swimming at 10 meters per minute. Shortest time. So perpendicular distance. So this is, I think this is the resultant. Now we have this V1 as 10 meters per minute. So since we are asked to find out only the direction, so we need to find out theta. Now look at what is theta here. Theta is nothing but tan theta, we can say tan theta is nothing but V2 by V1. So this was the angle theta. So this is the resultant. And tan theta we can write it as, so this is V2 . A river flows from west to east at a speed of 5 meters per second. In what direction should a man on the south bank of the river swim so as to cross the river in the shortest time if he can swim at 10 meters per minute in still water? So let us try to start with a diagram for this. We have the river. The river is flowing from west to east with a speed. The speed of the river, we take it as V2. This is 5 meters per minute. There is a swimmer who wants to cross the river in the shortest time, which means that he will have to follow the perpendicular distance. This is the resultant velocity, and this is the velocity of the swimmer, V1. This is the angle, theta. So we are provided with V1. It is 10 meters per minute. So we need to find out the direction in which the man will be swimming. So to find out the direction, we need the angle of theta. We can write sine theta as equals perpendicular by hypotenuse, that is V2 by V1. Now V2 is 5 and V1 is 10. So we get theta as equal to 30 degree. So we can see that the swimmer will move 30 degree. Now which of the option is correct? He'll be moving west of north. This is the north direction he'll be moving, and that too the west side of the north direction. So option C stands correct. Now the angle that the vector A equal 2i cap plus 3j cap makes with y-axis is. Now the angle any vector makes with the positive x-axis is given by tan inverse ay by ax. But the angle made with the y-axis will be just the opposite. So the angle made by vector A with y-axis is tan inverse of ax by ay. Now here vector A is given as 2i cap plus 3j cap. So you can compare this with ax I cap plus ay j cap. So ax is 2 and ay is 3. So if you put that here, you get tan inverse 2 by 3. So option C stands correct. Now two vectors, vector A and vector B, are such that magnitude of vector A plus vector B is equal to the magnitude of vector A minus vector B. We are asked to find out the angle between the two vectors. Now what is the magnitude of the resultant of two vectors, the sum of two vectors? Now let us try to solve this. We have the magnitudes. So modulus of vector A plus vector B is equal to modulus of vector A minus vector B. So what can we write this as? Modulus of this is nothing but square root over A square plus B square plus 2AB cos theta, where theta is the angle between the two vectors. This is equal to square root over A square plus B square minus 2AB cos theta. So squaring both sides and cancelling out the common terms, we are left with 4AB cos theta equals 0, or cos theta equals 0, which means that theta is equal to 90 degree. So angle between such vectors is 90 degree. Now the vector I cap plus vector j cap has the magnitude. So here most students make a common mistake. They think that I cap is a unit vector, so its magnitude is 1, while j cap also has a magnitude of 1, so the sum becomes 2. But that's not right. You have to add them thinking of them as two vectors. They are two rectangular components of vectors. So their resultant, the sum, will be given by, their resultant is actually given by root over I cap square plus j cap square. Now each is of unit magnitude. So this is 1 square plus 1 square, which gives us a resultant of root 2. So this option C is correct. So we have presented the entire theory of vectors and some relevant examples in a very concise manner. Hope you understand the concepts. Thank you.